Hello class, welcome to the lecture on vectors, and in this lecture we're going to be talking about some of the more basics and fundamentals behind vectors, including what we're going to start off with this first segment, which is the definition of a vector itself. What makes something a vector and what makes something not a vector. So the definition of a vector goes something like this. A vector is some sort of quantity that has both magnitude and direction, meaning it's got some sort of value directed in some direction. And usually when we're working in the atmospheric sciences, we're dealing with something that has something like velocity, some sort of physical quantity like velocity, which has wind speed directed in some direction. So an example, this might be a wind speed that's, say, moving north at 30 miles per hour, or even something more physics oriented, which is a car driving north at 30 miles per hour. This entire quantity has both a magnitude, which is 30 miles per hour, and a direction, in this case just driving due north. But this whole idea behind velocity is some sort of movement that involves both speed, involves both magnitude and direction, where the magnitude itself, by itself, is just called the speed, and then the direction is just what direction it's moving. There's not much else to say about that. But this also could represent some sort of physical quantity like a force, directing so many newtons of force in some direction, or this could also be something like momentum. Other physics-related quantities are like magnetic field or electric field, electric force, other stuff to that effect. But most of the vectors quantities that we work with in the atmospheric sciences are velocity and forces, which usually we represent in terms of newtons per kilogram. But if you're looking at what's strictly considered to be a force, then you would be having a quantity that has units of newtons. And in this case, we have another example of a vector quantity, which is a force of 100 newtons directed directly downward. And during the course of this lecture, we're going to primarily focus on two-dimensional vectors, meaning we're only going to focus on vectors that occur in both the x and y directions. But of course, in the atmospheric sciences, the atmosphere is very much a three-dimensional object, so we might have to worry about vertical components of our vectors at some point along the line. But for now, for this particular lecture, we're going to focus mostly on just horizontal vectors, that is, vectors that have are in the x and y direction only. We're not going to worry about the vertical direction of a vector just yet, but you can absolutely have a vector that extends in the vertical direction, such as is given in this example here, 100 newtons directed directly downward. And this is in contrast, a vector is in contrast to a scalar quantity, which only has magnitude. There's no direction involved in a scalar quantity at all. If you've got both magnitude and direction, you've got a vector. But if you only have magnitude and direction is either non-existent or irrelevant, then you've got a scalar quantity. An example of something like that would be a car driving at 30 miles per hour, period. No direction specified means that this value right here, this quantity 30 miles per hour, is a scalar because it's only got magnitude. It does not have direction. And another example of this might be the mass of an object. It'd be kind of funny to think about a mass being 5 kilograms of mass directed upward. But that doesn't really make a whole lot of physical sense because it's not really, a mass isn't something that can really be directed. It can't be given a direction really. So usually mass is just represented as just a simple scalar value. Force is another story. Force very much has direction, but mass itself does not have direction. Direction's irrelevant in the case of mass. And since since direction is irrelevant, the only value they can report from that is a magnitude, hence why the mass of an object is considered to be a scalar. So again, a vector has both magnitude and direction. So it can be any quantity that has both magnitude and direction, but a scalar only has magnitude. Direction is either not involved or it's irrelevant. So that's going to do it for this first segment, just introducing the concept of a vector. And in the next segment, we will talk a little bit more about some of the math that goes into vectors. So with that, I will see you all in the next segment.